Hello everyone, hope you all are doing well. In this video, we'll discuss the fourth problem of Leetcode Weekly Contest 292. It's a hard level problem. The problem name is check if there is a valid parenthesis string path. So the question says that a parenthesis string is a non-empty string consisting of this opening and closing braces. It is valid if any of the following conditions is true. So these are the three conditions. So even if a single one is true, then we are good to go. Um, so the first one is it's an empty pair. That means a opening and a closing bracket. The second one is it can be written as uh, AB. That means A concatenated with B, where A and B are valid parenthesis strings. The third one is it can be written as opening brace A and then closing braces. That means and where A is a valid parenthesis. That means if there is a valid parenthesis and we put another valid parenthesis inside it, then that is also known as a valid string. So we are given M cross N matrix of parenthesis grid. A valid parenthesis string path in the grid is a path satisfying all of the following conditions. So the conditions are the path starts at the upper left cell, that means 0 comma 0. The path ends at the bottom right cell, that means m minus 1 n minus 1. And the path only can move either in down direction or in right direction. So from a particular index we can move either in the right or in the down direction, and the resulting parenthesis string formed by the path is valid. And we saw what is a valid uh, parenthesis by these three conditions. So we need to return true if there exists a valid parenthesis string path in the grid, otherwise we need to return false. So in short, given a grid with some opening and closing braces, we need to start from the upper left cell, and we need to move to the bottom right cell. At each step we can either move in down direction or right direction, and all we need to tell is that whether we can obtain a valid parenthesis or not. That's the gist of the problem. So if we look into the example given, then this is the grid, and there are two possible ways of obtaining a valid parenthesis that is represented by the green color. So we start from the first cell, we move down, we move right, down, right, and again down. So this is one of the paths. The second one is represented in the second diagram. If we look into the second example, then we can't obtain a valid parenthesis because we start from the first index, and that itself is a closing brace. So we can't obtain a valid parenthesis because at any particular point of time it should start from an opening brace, but here it is starting from a closing brace, so we can't do anything about this, so we return false. These are the constraints. The grid length and so m cross n matrix, so that can go up to 100 comma 100, 100 cross 100, and grid of I comma j can either be a opening brace or a closing brace. So let's see what could be a possible approach with the help of a diagram. uh, Okay, yeah. So suppose this is a grid that we are given. This is a grid, and we have some cells here. We have some cells. We need to start from this. We need to end from this end at this index. Uh, so now what we can do is that, so at any particular point of time we can either move in the right direction, change the color, or we can move in the down direction. And we at any particular point of time it should be a valid parenthesis. Okay, so what are valid parentheses? Let's take some examples. So opening, closing. It can be opening, opening, closing, closing. It can be opening, 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 closing, closing, again opening, again closing, and closing. So see, this is a pair, this is a pair, this is a pair, and this complete is a pair. So this represents a valid string. So this seems to a to be a basic DFS problem. We can start from this index. We can start from this index, and we can uh, traverse the possible paths. Now, what are the possible paths? From this position, we can either move right or down. So we start moving down, for example. Now from again here we have two options, either we can move right or we can move down. So at every particular point of time we also keep a track of what are the parentheses that we have seen. So one of the ways is that either we do it in a string format, or the second one is that we take a variable, let's call it a balance variable. We initialize it by 0, and as soon as we encounter an opening brace we increment balance, so we do balance plus plus, and as soon as we encounter a closing brace we do balance minus minus. So that means a valid parenthesis will have balance equals to 0. That means equal number of opening and equal number of closing brace. Also, at any particular point of time the value of balance cannot be less than 0, because that will mean that we have more number of closing brace as at a particular point of time, which is not valid. Like for example, this example, two two closing and then two opening, so the balance sum will be 0 for this case. But at these two, at as soon as we start, we can see that for the first position the balance is minus 1, so that means it is negative. So that means it's not a valid parenthesis. So two conditions. The first thing is that balance can never be negative, otherwise that is a invalid string. And the second one is that as soon as we reach the end index the balance should be 0. That means till here we have equal number of opening and closing brace. So as discussed, we can start with a from the starting index we can either move right or in the down direction. We can keep on updating the balance value. So increment if it's an opening brace, decrement if it's a closing brace, and yeah, just keep track of what are the cells that we have already visited. So we can do that by using a boolean array or something like that. Also there are three things that are changing here. One is row, one is column, and one is balance. So we will need what we have done in the code is that we have taken a three-dimensional array to keep a track of what are the things that we have visited, because row and column, that means the current row and the current column, that means suppose this index, and balance is for keeping a track that if we have visited this cell with this particular balance, that means we have already computed the result for this one, either it's true or false. If it would have been true, then we would have got our answer, but since it is false we don't need to go to the same path. Like for example, if by traversing some way we reach to this index, and again by traversing in another way we reach to this index, so r comma c is common, and suppose the balance is also same via this path and this path, that means we have already computed the result for this one. No need to do it twice. Like for example, if we traverse in this way, no need to do it when we are coming from here to here and again from here to here. Just do it once. So that's sort of a technique to avoid repetitive traversal. So yeah, this is the basic technique that will be following in the code. Let's look into the code. So just a second. Yeah, so here is the solution. So this is the main function. We have initialized, so we have added a couple of attributes in the class so that we don't need to pass the grid every time in the function. So yeah, this is the grid. This is n cross m grid, and we just call dfs with value 0 comma 0 comma 0. So here 0 comma 0 means the first 0 means row index, the second means the column index, and the last one means balance. So we start with balance equals to 0. Now as soon as we come here, we update the value of balance. So it is 1, we increment it by 1 in case of an opening brace, else we decrement it by minus 1. uh, we check if the balance is less than 0, or this cell has been visited. That means this cell has been visited with this particular given balance, we just return false. Because if this cell, if this path would have given us the correct answer, then we would have not come to uh, this traversal. So that's why we return false, because this path will anyway give us the false result. We mark the current combination as true, the visited as true. Now we see that if we can move in the down direction, no sorry, in here we check what is the index that we are with. So it's if we reach to the bottom right index, that means I equals to n minus 1 and j equals to n minus 1, and the balance is equals to 0. That means we return true, that okay, there is a valid path and we don't need to move forward. If this is not the case, then we check whether we can move in the down direction or not. So if I is less than n minus 1, and so if this is true, then we call DFS with the same column and the next row, that means moving in the down direction with the given balance, and if it comes out to be true, we return true. Similarly we do it for the right direction, movement in the right direction. So if j is less than m minus 1, and DFS of I comma j plus 1 with the current balance gives us the correct answer, we return true. And yeah, this will give us the answer, and if none of these conditions satisfy, then we return false. And finally we see that whether we have a given a valid string or not. So the time complexity for this one will be, so we are traversing each cell only once. So that means big O of n cross m, and yes, we have taken space. Space is, I would say, n cross m. So it's a constant, not constant, but in every case, since the constraints are 100 comma 100, so we have taken 100 comma 100 comma 200. So this is the space taken in the solution. So yeah, if you've learned something new from this video, then please support it by giving up a thumbs up, do subscribe to the channel, and yeah, see you in the next video. Bye bye.